Hi everyone, so today let's solve the problem 435 non-overlapping intervals, right? So let's see what the question states here. So we are given a list of intervals, so nothing but here this one is start and this one is end, basically the intervals part, right? Start and the end. So we have to remove the minimum number of intervals so that the rest do not overlap, right? So when I say we have to remove the minimum number of intervals so that the rest do not overlap, so it is touching at a point as allowed, basically, right? So we have to remove the minimum number of intervals so that the rest do not overlap, right? So we have to return the minimum number that is removed, right? So constraints they have given up to 10 to the power of 5 1e5, also known as 1e5, right? So this one, start greater than or equal to minus 5e4, this one, right? And end greater than start and end this one, less than or equal to start and end less than or equal to 5e4, right? So that's what they have given here. So this is fine, man. This is fine. Now let's do one thing. See here, let's come to the first example here. We have 1 2 2 3 3 4 and the 1 3, right? So here, so 1 comma 3 can be removed and the rest of the intervals are non-overlapping here, right? So this one, see, 1 comma 3, so this one comes between this one, this overlaps with 1 comma 2 and also it overlaps with the 2 comma 3 and also it overlaps with the 3 comma 4 as well, right? So this 1 comma 3, so when we remove this 1 comma 3, so 1 comma 2, this one, basically 2 comma 3 and 3 comma 4, so these are non-overlapping, basically 1 2 2 3 3 4, right? So this is fine. So 1 comma 3 can be removed and the rest of the intervals are non-overlapping, right? So here, next example, second example, they have given 1 comma 2 1 comma 2 and 1 comma 2. See, we need to remove 2 1 comma 2 to make the rest of the intervals non-overlapping here. See, we have to remove, so this one is overlapping, right? So 1 comma 2 overlaps with 1 comma 2, same thing goes for this one. So let's remove these two, so that this is non-overlapping. So 1 comma 2 remains here. So 2, the number of, we have to return the minimum number that is removed, right? So 2 here in this case, we have 1 comma 2 and 2 comma 3, so this one doesn't overlap at all, right? So 1 comma 2 and 2 comma 3 doesn't overlap at all, so here it is non-overlapping and we have to return the minimum number they have mentioned here, so we will be returning 0. We don't need to remove any of the intervals since they are already non-overlapping, right? So this is fine. They have given us wonderful examples just for the sake of understanding, right? So this is fine, man. Now as we have the idea, right, as we have the understanding of the question, let's do one thing. Let's discuss the approach. Let's consider the same first example, and for this, to solve this problem, we'll be going with a simple math as well as the using sorting, right? So usually the intervals questions, so we will be making use of the sorting, right? So mostly we will be going with the sorting, so sorting and math, right? So this is fine, man. Now the first step would be, we'll be considering the first example itself, right? So the first step would be, we'll be sorting the intervals by their end time. So again, merging the intervals, we went for the merging the intervals question, we went with sorting the this one, sorting based on the start, basically. For the this one, what do we call, removing the non-overlapping intervals. So this one, what do we call, we have to remove the minimum number of intervals so that it does not overlap, right? So for removing the number of intervals so that this one intervals doesn't overlap, so here in this case we will be sorting the intervals by their end time, right? Sort, first step is sort by end time. So end time, I'll just write it here, et, right? So by sorting by end time, we get here this one output 1 comma 2, this one, after that we get 1 comma 3, so 1 comma 2 1 comma 3 becomes, so because after 2 we have 3, right? We are sorting based on the end time, 2 3, then we have again we have 3 here, then we have 4, so we have to go with 2 comma 3 and 3 comma 4, right? So this one will be 2 comma 3 and finally 3 comma 4. This is fine. So yep, this is nothing but we are sorting the intervals by their end time, earliest and first. For the tie, sort by the this one, start. After sorting we get so whatever that I have written there. This is fine. Now we'll be going with a greedy. greedy approach, right? So we'll greedily pick, basically always keep the interval with the earliest end that doesn't overlap the last kept interval. We will be starting by the we will be starting by keeping 1 comma 2 basically, right? So last end would be 2 will be equivalent to the 2 last end, meaning the variable name last end will be equivalent to the 2 basically, right? So this is fine. Next so we will keep 1 comma 2, right? So next what we have, the first step we have 1 comma 2, this is fine. Next would be 1 comma 3. So it starts at 1 and the last end would be this one 2 we have. So this we have overlap here because we have 1 comma 3, right? So we have 1 comma 3 here for this one. So basically we have sorry, previously we had 1 comma 2, now we are considering 1 comma 3. See here, 1 comma 3 starts at 1 which is less than last of end, nothing but this one 2 basically, which is less than this value 2, right? 1 is less than this one, so this one is less than this one, right? Last end 2 basically. So this overlaps, so we will be skipping this one, right? So we'll be skipping this one. So now we'll keep only 1 comma 2, and what we will be skipping, we will skip this one 1 comma 3 as it overlaps, right? So next we will go with the 2 comma 3. Here 2 comma 3 starts with the 2 basically, starts with 2, and 2 is greater than or equal to last end of 2. So this 2 is greater than or equal to, basically which is equivalent to the 2 itself, right? Last end of 2. So we will keep it. So we will update last end equals 3 basically. So we will keep this one, right? So we will keep 2 comma 3. So we will update last end as 3. Now the last end is 3, not this one 2. Now we have the end, last end is 3. We'll move on with the 3 comma 4. So next we'll move on with the 3 comma 4. So 3 here it starts 3 is greater than or equal to last end 3. Basically 3 is equivalent to 3, right? So this 3 is equal to this 3, right? Last end 3 basically, right? So we will keep the 3, right? So we will keep this one 3 comma 4 in simple terms, right? So we will keep 3. So this one we have kept 3 comma 4, right? Total we have is 4 basically, right? So total we have is 4, and removed is nothing but this one, what do we call 3 we have kept, right? So this one will be total minus removed. So this one will be removed equals 4 minus 3 basically, total. So total we had this one, removed was basically after removing the non-overlapping we have this 3, we have this one 3, we have kept 3. So this will be total minus kept, which is equivalent to the 1 here in this case, right? So the output that we got here is 1, which is equivalent to the output that they have mentioned for the example 1 within the question. So our approach works absolutely correct here. Our approach works absolutely correct here. As we are completely familiar with the approach, let's move on with the complexities part. So what will be the time complexity and the space complexity here? The time complexity would lead to big O of n log n, right? So the time complexity would lead to big O of n log n due to the sorting, right? So where n is nothing but which is equivalent to the intervals dot length, the single pass greedy scan is big O of n, right? So this is fine. So what would be the space complexity here? The space complexity would be big O of 1, right? So the space complexity would be big O of 1 extra, right? So sorting in place aside from recursion or the tim sort overhead, right? Or we can just consider big O of log n if counting language this one sort, stack, or auxiliary usage. For the easy usage, for the easy one will be going with the big O of 1 itself, right? So this is fine. Not the big let's not consider big O of log n, right? This is fine. So the space complexity would lead to big O of 1 and the time complexity would lead to big O of n log n because sorting is the dominant factor here in simple terms, right? So this one, time complexity and the space complexity for the code that we'll be writing in the future would be big O of n log n and big O of 1 respectively, right? So now as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code. Yep. So if the input is null or empty, there is nothing to remove. So this is the base case. So we will be going with intervals if it is equal to null. So let me copy this intervals, man. we'll be using this one many times, right? So again, or intervals dot length, if this is 0, basically what we have to return, so let me close here, we have to return 0 in this case, right? So the next step would be we have to sort the intervals by end ascending, right, based on the end. Basically, if ends are equal, then we have to sort by start ascending, right? So this one, let me go with arrays dot sort of intervals a comma b, right? So this is fine. Intervals a comma b, let me write this one in the parenthesis or else it will be wrong basically. So let me write this one on the parenthesis, right? So this will be, this is fine. This let me write the simple if condition here. So the primary key here would be the end time, right? So I can just write it in this way. If a of 1, if it is not equal to b of 1 basically, so then we will return a of 1 minus b of 1. So this is fine. So primary key is nothing but the end time here. So let's go with the tiebreaker here, nothing but if the ends are equal, then we have to start by start ascending. So this one will be return a of 0 is hyphen b of 0. Just this is fine, man, we know this, right? So let me come out of this one entirely. Now we have to keep the count of intervals that we can keep without overlapping. So always we have to keep the first after sorting, right? So let me go with kept, let me initialize this 1 to 1. Also we need last end, which is equivalent to the intervals of 0 and 1. So this is fine. This is nothing but the end time of the last kept interval, we know this. Now let's do one thing, let's iterate remaining intervals and greedily keep those that doesn't overlap. So let's move on with the for loop here. This one will be int I equals 1, I less than intervals dot length. So this is fine. Let me increment I here. So within the for loop, so let me write the simple if condition, meaning here if the current interval starts at or after the last end, it doesn't overlap, right? So it doesn't overlap. We have already discussed this one in the approach, right? So let's write the simple if condition for it. If intervals of I, this one 0, if it is greater than or equal to last end, then within the if condition, let's increment the kept here, right? So we have to keep this interval, right? So we'll increment the kept. Then we also have to update the end of the last kept interval, meaning so we have to assign the last end to this one, intervals of I and 1 basically, right? So this is fine, man. Let me come out of this one entirely. Now we are left with only one step, that is nothing but we have to go with a number to remove nothing but which is equivalent to the total intervals minus intervals that we kept, right? So we can just return this way, you can just write it on this way. So this one will be intervals dot length minus kept, nothing but total intervals minus intervals we kept, right? So this is fine. So this is it for the code. Let me format the code once and let me hit the run button. So I hope this works, man. Let's see. Yep, this works absolutely correct, right? So this is fine. Let me hit the submit button. Yep. So here all the test cases are getting passed. So this is fine. All the test cases are getting passed. So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.